panel, the role of real-time monitoring in marine ecology. We have a brief change to the schedule, and I know if you're at like Broadway or watching a show, that usually means the understudy is taking over, and that is true here as well. We had some weather delays in the southeast, and that caused some travel delays. And Dr. Paul Gaze couldn't join us in person. We wanted to try to figure out a way to do it remote, and we just couldn't solve for all the things we wanted to take care of here. So I've had our moderator, Dan from Sofar, step in for Paul, and I'm stepping in for Dan. So you have the pleasure of the plucky understudy today, and it has got nowhere to go but up. So I really appreciate you guys and all of your enthusiasm throughout the day and patience as we've ridden the waves. So I guess we could probably cut the screen off there and just take it there. I'm hoping to leave some time at the end for questions. So I'm going to kind of run through these rapid fire, but we kind of mentioned this a little bit, but we've talked a lot about sensors, data collection, data acquisition. You know, to go from a temperature measurement to global warming is a big step, and every little like kind of viewpoint out, zoom out, higher altitude requires a different set of tools, a different infrastructure, and it gets more and more complex and more difficult as you get more and more sensors. And you know, to achieve like large scale, long-term impact out of the tools and the measurements and the insights that we're all talking about here, it really requires approaching it from a number of different ways. And so we wanted to assemble a panel that represented different steps on that journey. I think what I would like to do is if we could go down and just give a brief introduction. We've left about 10 minutes for this, but please take the time to describe kind of who you are, what your experience with ocean science or biology is, and kind of what you're working on currently that you're excited about. And then we'll dive into some more specific questions that hopefully will help all of us get a better understanding of what it takes to go to scale. So I guess we'll start, John, if you want to start us off.
Sure. Thanks a lot. My name is John Haskins. I work my day job. I work down at Elkhorn Slough, the National Ice Stream Research Reserve down there. We don't have a Sofar buoy, but I manage the water quality monitoring, the weather monitoring, the nutrient monitoring down there. And then I wear many hats. I do drone work and fly drones and make maps and monitor our restoration of the marsh down there. So I have been there for about 25 years. So I've had a lot of experience with water quality and throwing instruments in the water, and I've only lost one instrument in 25 years. That's a pretty good record. But lately, the last 6 years, I've been working with an organization out in Micronesia, just north of Yap, one of the largest atolls on the planet. It's called Ulithi. They played a major role in the World War II. That was where the U.S. Navy base was, because it's such a large atoll. And smack dab in the middle of the Pacific. It's way western Pacific. They approached the founders of the organization a little over a decade ago, because their fish populations were going downhill, and they were trying to figure out. They live out there. They're all subsistence. They're living off the reef. So trying to do conservation is very coupled with the humans, because they need the fish to survive. So about 5 years ago, we worked with Aqualink and got a Sofar buoy. COVID, we couldn't put it in. I think we got it in 2019. We just put it in last January. So it's been out for almost a year, and they're ecstatic about it. They're super excited. The organization, the One People One Reef, is very much community driven. So we're a kind of a group of scientists. There's some ecologists, some reef ecologists, some fish ecologists. They're doing really high level science. They're doing genetics, metabolomics. I'm doing the water quality. They're doing underwater drone imagery. But it's all driven by the community. The community is asking the questions. The community is driving the research that we're doing to answer their questions. We're not driving any of the questions. And so to get them a SOFAR buoy, to get temperature, that just gives them more information in real time that they can see if it's really cool to have that heat index, so they can see if that area of the reef is stressed already. Then they can change their management, adjust the way they're managing. They're super tied with their heritage and their culture, and we talk about traditional knowledge, but I just heard recently it's more traditional science. They've had this knowledge for thousands of years. And so we're just coupling their traditional science with Western science, and that's developing. But they're really stoked to get this instrument out, and we would love to get Bristlemouth. We're trying to get one. So if anybody wants to make some donations to One People One Reef, we're trying to get a Bristlemouth out there so that we can get some more parameters. There's in Yap, they're looking to, they're expanding the airport there, and the Navy is trying to expand the harbor. And so they're super concerned about turbidity. So maybe we can couple a turbidity on a sensor.
Let's try to make that happen.
Yeah. So I don't want to take up more time, but that's where I'm coming from.
Hello, everyone. My name's Alberto Morales, and I'm a graduate student at UT Austin. Right now, I'm currently studying ocean acidification as well as the interesting effects of brine in the West Flower Garden banks. You might have seen the poster over there. It has a really cool manatee on it. If you want to learn more about it, I recommend reading the poster. Originally, though, my background is not marine science. I have a background in engineering, and I used to work on virus machines until deciding to go back to school. And now I'm studying, marine science in Doctor Who's lab, which he's a great scientist. So if you have any questions, I highly recommend Googling him. Doctor Who at the University of Austin. And our experience with the bristle mouse so far is for studying the kind of brine effects, as I mentioned, in the West Flower Garden banks, because recently there have been localized areas of mortality, and we're kind of working to prove the theory of where that's coming from, how it's happening. And yeah, I think that's pretty much it from me. A very short introduction.
No, perfect. Thank you.
Thank you. Hello, everyone. My name is Caesar. I work for a philanthropic ocean monitoring organization. We provide free tools publicly through our online platform. We also operate a large fleet of more than 160 SOFAR smart marine buoys worldwide through our citizen science network. And these SOFAR smart marine buoys, they transmit wind, wave, and temperature data in real time. And these also stream data straight into our public dashboards that we have available. We also have hundreds and very, very soon thousands of sites on Aqualink where people use our tools to monitor their local reefs. And on Aqualink, you can monitor both oceans and reefs, both locally and globally. All of our dashboards and the interactive map are both powered by wind, wave, and temperature data from NOAA satellites. We also support the integration of almost any type of sensors into our platform. We have users, for example, that have integrated water quality data, biodiversity data, and some even have live streams connected to the dashboards. So you can do a bunch of different things. But what we believe the community really wants is temperatures, sensors that transmit data in real time. So this with BristleCon is super important. And if anyone has sensors they want to integrate, we are more than willing to help to work with you guys. On Aqualink also, you can combine data with visual observations to really provide an instant view of your reef's health and so on. So if you're interested in learning more about our project or on Aqualink, feel free to ask any questions. Also, Aqualink will tomorrow have a workshop where we will show our platform and show you how you can integrate what you're working on into all platform. So feel free to come to that one.
Great. I am not Dr. Paul Gaze, which, hello, I'm Dan Breyre. I'm the product lead at Sofar, and I'll do my best to live up to Paul's high bar. But I'm not here to really talk about Sofar as an entity. If you have questions about that by now, should, I don't know, rewatch what happened this morning or talk to your CTO or CEO. I'm here to talk about what represents Sofar as a network of sensors. We've got the most out there, over 1,000 and counting, both our own and that we operate and also support other people building their own networks. And that poses a really unique challenge that I want to share and kind of talk about. Really, it's this intersection of if you want to do good work at scale, scaling what works right now breaks down. You have to take a different approach when we start talking about networks and large fleets, and here to share some of the things that we've learned the hard way when managing this size of sensors. So excited to be here.
Yeah, thank you all for those introductions. So I guess I'm going to start off with some questions of my own that Dan wrote, but we're gonna.
They're really good.
So you have to watch me read your questions to you. This is going to be fun. Real live TV, folks, live TV. But they're great questions. And then I'm going to leave as much time as possible for questions from the audience, because never before have we had the high density of experts in the room and a high density of variety and depth on our panel. So I'm really excited to connect you guys here. So the first thing is Dan, you kind of teed that up very well. Thank you. Very insightful. One of the things that I would like to ask each of the panelists, and we can kind of pick and choose who goes first. Maybe we'll start with John. But like, what are the insights? What are you hoping to learn with your instrumentation? What decisions are important or critical? And how does that change when it goes from like, I'm writing a scientific paper. I'm going to drop a logger in. I'm going to pick it up next year, and then I'm going to write another paper, or that informs my next avenue of inquiry. What changes when it's real time? Like, are operational decisions, or people deciding? Like, I'm curious on was it YAP or Ulithi? Yeah.
Cool.
So yeah, please.
Yeah. So I mean, when you're placing it out and you want to study something, you're putting it out for a specific purpose. You want to look at temperature, you want to monitor the temperature to monitor the reef and see about heat stress. And so then you're answering that specific question. I think when it's real time, you get to be able to see if there's some new event that you didn't experience, that you didn't expect to happen. You're getting the data right there, right then and there. The other thing that I was thinking about is that it's so much easier to engage the community when you have real-time data instead of when you're showing old data. And it's really hard to make. I've been trying for years to try to figure out how to make water quality sexy. It's hard. To people that are not geeks. To geeks, it's easy.
You're in the right room.
Yeah. But to the general public, it's kind of hard. But when it's real time, you have so much more, you can pull it up on your phone. And that's another thing that to really engage the youth of today is now if you can pull something up on your phone and go, look, this is what the temperature was in the last hour, or this is what the dissolved oxygen was in the last hour. Look how it changed. What was the tides happening? The sun was going down. So, you could start engaging in real time that.
I have some follow-up questions for you, but that's
Yeah.
actually a really good transition. Caesar, on Aqualink, you guys have spent a ton of time and energy on the user experience, the data visualization. Like, why that? I mean, obviously it has a value to itself, but why that approach? What do you guys get out of that? Why not just click here to download this spreadsheet?
Yeah, it's like what he says, like if you visualize the data, it's so much more intriguing. And it's also good because on Aqualink, for example, we take for example, the Sofar spotter data. We take the data, automatically creates graphs, we create dashboard cards, and this becomes fun to look at. So it's intriguing. And also you don't have to think about analyzing what's on it because you already see it's right there. So, we really work on the fun side of things, like creating fun versions of data.
Yeah, more than fun though. With 6,000 sites, you got to imagine some people are really using this for monitoring. They're responding to
Yeah.
bleaching events, right?
Yes, for sure.
Yeah.
And that's for like the real-time monitoring. It becomes so important because for all of our users, it's time cost. It costs time and it costs money to go out and deploy sensors, retrieve them, and the time in between there, you have no clue what's actually happening in the reef. So the real-time data is so important because you get to see exactly what's happening during that period of time. And this response time, for example, for coral bleaching or coral diseases can drastically decrease if you know what's happening right now and then. You don't have to wait 2 months to retrieve a sensor to actually understand what's going on. So yeah, it's really important too for monitoring to visualize it straight away.
And thank you for painting that picture. Alberto, I wanted to ask you, I could imagine at Flower Garden, some of the challenges are the same, but you're talking about brine or, very salty water, or potentially not so salty water. What does the real-time aspect give you guys that traditional logging couldn't? Or I would also ask the question, what are you hoping to learn by switching over to real time?
Yeah, that's a good question. I would say that sort of real-time data gives us a better look at things. Sort of as Caesar mentioned, that you don't have to wait so long to understand what's happening. And in the flower garden banks, because there's a lot of like in recent times, there's mortality events. So it's sort of like trying to diagnose something. And if you don't have the data in real time, you do have to wait that extended period of time just to understand what's going on. Additionally, because it's so far out there, it's about 100 miles off the coast. In order to save battery time, we have to, cut certain things. Like we can only measure samples at certain amounts of time, or for certain months out of the year. And with real-time data, we're able to sort of see all the symptoms that are going on inside of the West Flower Garden banks. We're not going to miss anything. Like if we were only sampling partially out of the year, or if we were only sampling like every hour, there might be something before that hour that we miss. There might be a spike in something and suddenly we're just getting the after effects. So I think with the real-time data, there's actually a lot more data to look at and you can make a lot more decisive decisions. You can act quicker, things like that.
Yeah, awesome. Thank you. And Dan, I think you must see some pretty crazy operational use for Sofar data. I'm imagining with this large sensor network, there's probably a lot of people that are using it for safety, using it for work. Like, what are some of the things that you've noticed that's like, oh, it's got it for us, it's got to be real time?
Yeah, for our customer base, operational customers need to make decisions about what they're going to do right now because it costs them time and money. Every boat operation is tens of thousands of dollars, and the risk of life for wind farm operators or for anything else is incredibly high. And you can't do those decisions using historical data. It's just not possible. History is great, but not great for right now. And then what has been most interesting is understanding the relationship between right now observations versus where something is happening in the future, forecasts. So if you looking to my ocean scientists, including my CEO, have told me many times that if you want to know what's going to happen at a location, you need to measure where that climate or where that weather is coming from. And so having real-time sensors that can track as those things are basically coming towards your area of interest, so you can make a decision about in the next hour or 4 days, when is a good time for my craft to go out? That's everything, right? There's no amount of historical data that's going to be more beneficial than being able to look at that data and make that decision.
Thank you. Yeah, super insightful. I think, we're doing a good job here at Sofar to putting a lot of these use cases up on the blog, but what happens at scale? Like, for example, maybe something that most people might want to hear about is what is it like operating a network of 1,000 sensors? And this question's coming to Caesar. Same question to Caesar after this.
Stressful. It's when you start talking about true networks of sensors, the challenge completely changes. It's no longer a limitation of engineering horsepower or capital expenditure. It's now, how do I maintain the data flow? The sensors almost become irrelevant, and it's how do I maintain and grow the pipeline of information? So CapEx goes away, OpEx now becomes the big question. Who's going to fund all of these devices for X number of years? Who's going to manage them? Who's going to be doing controls and quality checks on the systems and the data itself, right? I need more servers and I need more data engineers, because I can't just go out and pull up the system and say, oh, nope, got biofouled. No, we're talking at a much grander scale. And so the types of challenges that you're now facing and who you have to engage with, governments, territorial managers, permits, like those are things that keep me up at night, in addition to, does a particular integration work, or will it actually transmit data?
It's fascinating. Thanks. And Cesar, I have a question that's really similar. Like you said in your introduction, you're going from 800 to 6,000 sites pretty soon.
Yes.
What's that going to be
Next
like?
week, probably. But that's dashboards and not really real-time data. All dashboards, as I said before, are powered by NOAA satellites for both wind, wave, and temperature. But if you come to the workshop tomorrow, you can also see what the difference is between satellite sensing and in situ sensing. We can see a pretty clear difference. So it won't be too different, because that's the online platform.
So you're pulling data from pre-existing sources.
Yeah, that's
they're
from
doing
NOAA
all the quality
satellites.
control.
Yeah,
Right.
So
I might adjust my question slightly to be, now as a user, where am I going to know where to look? Like I'm just landing on the splash page. I'm just imagining I'm just inundated with this data. How are you going to let people know what's interesting or what's relevant to them?
Right. So what we have created at Aqualink is a public platform where you can add your own data, and you can monitor your own reef for your own purposes. And you can also look at other data. So like all the data is publicly available. We believe that everything should be publicly available at Aqualink. So we're trying to make it as engaging as possible for different purposes. We're mostly into the coral reef aspect of things. But yeah.
Yeah, so it sounds like the answer to that is you choose your own adventure, right? If you're interested in this hyper-local site, I got all the tools I need to pull that. But if I'm interested in broader trends, I also have views and presumably filters to get at that.
Exactly. It's mainly like, you're going to see ocean data. You can find it on Aqualink for sure.
There you go. All right. So we'll switch gears just a little bit. I wanted to ask you, Alberto, as you're doing a lot or just stepping through the threshold here on electrical integration for ocean science, we've talked a little bit about it today, so it's not surprised that it can be difficult, but specifically for you and your experience, what's been tricky to step into this world, and what's been hard? Has it been tough to get a hold of manufacturers? Spec sheets are all old. Like what's your life like? What's your day-to-day?
I would say the hardest part of getting like sensor data, processing, anything like that is just the logistics of it, especially like like I was saying, the West Flower Banks, it's 100 miles off the Texas coast. So you need to take an overnight ship to get there. It's under maintenance right now. And also we're under, the kind of, I can't find a word. We're under the scrutiny of the ocean. So weather, events, the environment, microfouling, anything like that, especially because we put those sensors so far off the coast, whenever they go down, they go down. Like there's no way we can just say, oh, let's drop everything and drive 100 miles off the coast, off the coast, go rescue this singular sensor and go back. It takes an entire team just to do so. So that's what I would say is probably the hardest part, getting all those people to come together just to do a bunch. Also, you have to put all your eggs into one basket, saying that on this day, we're going to do X, Y, Z. We need to accomplish all that, or else this entire trip is essentially a waste. So
Thanks for sharing that. And John, how does this change when you're not dealing with specialized, well-trained folks like yourself? How does this change when it's across the planet and you have to do this over WhatsApp?
Yeah. You, it has to be, you're hoping those sensors are super robust.
Yeah.
And that they're going to be able to do the work for a long time, but very similar situation where we're super isolated. So going to get other parts is going to take a couple weeks or
So
I
no,
guess.
no McMaster car and
No,
No.
no Amazon Prime to send stuff. So yeah, and I think it's a lot on us to make sure that we're doing that when we're doing the training for them, to make sure that we're trying to think of every possible scenario that might come up for them in the future so that they can be prepared.
All right. So I've got the cube out, which is, as everyone knows, audience participation time. Are there any questions from the audience? All right. Gonna do the alley-oop, Jim. Behind you. One more.
Okay. The question I have has to do with, it's more of a question around how the sampling is done in the various cases that you guys are talking about. Is anyone thinking about leveraging some of the event-based sampling strategies? For example, event-based cameras, which you might have heard about, sampling structures that actually pay attention to the information theoretic side of it, that are looking at what has actually changed in the data stream as it's being collected, so that the amount of information that's coming back is dramatically reduced. So it's like, instead of collecting all of the data at every sensor, all the time, every time you take a sample, if the data hasn't changed, there's nothing really to report, if you follow what I'm saying. I'm curious in this domain, whether or not that's something that would be of value to the kinds of projects that you guys are talking about. Is that clear? I'm not sure.
Yeah.
Yes. So that's exactly the dream that I think we have. When I talk about that operational cost, transmission is one of those.
Yep.
We're talking hundreds, thousands of sensors. That's super expensive in places that data movement is really hard. And we don't have the luxury of terrestrial infrastructure where we can send all the data and fix it in processing sensors and train ML models. So what actually the presentation earlier today on the Borealis is like the tip of the iceberg of this concept. How do you use something like Bristlemouth and a network of systems intelligently to make decisions on-prem in the edge, waking up sensors that are power hungry just when you need them, making inferences, turning on a camera or a hydrophone, telling you the information you need, and then just squeaking out the exact amount to make a decision. So what you're getting back is not, for me, 1,000 sensors with time series data, but one decision point of, yeah, that was an illegal fishing vessel. You should probably go scramble. That's absolutely the dream of having these networks. And we need the technology to be able to do that, sadly, in the harshest environment known to mankind.
Yep. Yeah, perfect.
Awesome question, awesome answer. Were you gonna join in?
Yeah, just
please,
one
go for it.
thing. Just kind of well, what you said about even if there's nothing to report, I would say that that's still pretty significant. Like in science, we're always asking the question of anything, like does X affect Y? So in my like particular thesis, I'm studying ocean acidification in the ship channel. And so one could ask a question, does this river affect the ship channel? So if there is nothing to report, that's still pretty significant as to say, yeah, this river does not affect it. So I think that that's a pretty good point. That's something a lot of people they sort of glaze over. Oh, this didn't change. This doesn't mean anything. When in fact that, yeah, there is no change. That means that we can for sure say that if you were to dump something here, it's not going to affect something. Y is not going to affect X, and X is not going to affect Y. I think that's just the point I wanted to get across. But yeah, it was good. I like that question that he asked.
Always with a good question. You can count on it. All right, you've got the blue cube. Who's doing the blue cube? All right, we've got behind you as well, and then in front of you.
Yeah, you guys have been talking about networks a lot, and I was just curious, so it seems a lot of hardware standardization and things like that. What about anything that'd be like mesh network or something that would be something that these ocean probes and stuff could talk to each other? I mean, especially if we're talking about having sensor data aggregation and being able to get less things that, I mean, satellite is not cheap. I mean, even, in the middle of the ocean, right? So is there kind of plans for that? Any sensors talking to each other, mesh network size?
Brave souls.
It's a great idea. And you have all the people that you need in this room to help solve that. No, that's a good point. And when I think of diversification of assets and platforms, it's exactly that. How do you have things communicating to one another so you can do that? My dream is that by the next BristleCon, we have Bristol Mouth native acoustic modems and new telemetry modules that use maybe LoRaWAN or Certus or something else. Like there's so much that is available. And so, yes, definitely. And it's up to the people here to help us get there.
Cool. I love this. No softballs for the panel. Who's next? Got up front, Jim.
Yeah, so I was thinking, maybe I'll focus on Aqualink a little bit, but it's true for any dashboards here. So to make your stuff more compelling to a broader audience, right? It's nice, it'd be nice to have stories like, okay, and I think you're doing a little bit of that, like, okay, here's all the data, but there was this hurricane or something event or whatever, here's the data and the data shows it. So there could be an emergence, or you may want to encourage what I might call data influencers, to coin a horrible term. So there could be these people who, go through data, find interesting things, and they have a social profile that points back to your dashboard. Thought?
Yeah, I love the idea. Aqualink is a small team, so that would be up to me probably to do that part. But maybe I can work on it.
Well, you got to
No.
start hanging out in millennial bars or something.
Yeah. No, yeah, I do love the idea. And the thing with like public data as we have is that everybody can access it. So if someone actually wanted to do it, even from this audience, like you can literally get all the data we have available. And that's really the power of public data. The data can reach the person that can use it the most and do something really valuable with it. So Maybe that's a influencer. Who knows? Yeah.
I might take a swing at that too. Storytelling is core to what
Right.
Bristlemouth and Sofar do as well. And often this comes up when you're speaking to classrooms and they're like, I'm not gonna go into engineering. I'm gonna go into business or English. I'm gonna be an English major. I'm gonna write. And what's been really profound about this journey that we've been on here is like it takes a village. It takes a marketing team. It takes uh, journalists. It takes organizers just to crack the whip. I mean, I'm on schedule. That wasn't natural. Somebody had to make that happen. And so I think at the core, interestingly enough, with this panel, at the core of I think what everyone's doing is a big component of storytelling. The poster on the wall at Flower Gardens. I mean, are you guys have other plans to get the word out? Local news? Do you guys have a Flower Gardens spokesperson?
So we have researchers and professors working with like the local community and schools, like people like me, better talker grad students that actually go out to schools and they talk to all the kids, and we're hoping that like we're bringing the community together to understand what's going on. But I think for influencers, like if you were going to post on YouTube or make those shorts, I don't know. You'd have to talk someone into doing that, because if you're wrong about it, then everyone's going to be like, "Oh, you're wrong." Like, so I think that's the big fear, at least coming from me. I'd be like, "Oh no, now I have my PI commenting like, actually, it's supposed to be this,"
Well, that's the beauty of the influencers. There's no accountability.
Yeah.
Yes, I will unsubscribe from that TikTok if it's not entirely accurate. You guys do a great job with storytelling. Tell me a little bit about what some of the plans coming up. But
Yeah, with the Elkhorn Slough Preserve, we do a lot of work with the public, with the students coming in. And so whenever there's an event and then in the data like that, what was that, 2011, the Japanese tidal wave that came across, we actually saw that wave come across into the slough, and then we saw a seiche in the slough for days. And so it's kind of fun to plot that data and then give it to the students and be like, what do you think happened? And then they can get engaged with that. But so yeah, we have a lot of curricula that's based on the data that's generated. We were able to see during the 2017 eclipse, we had weather data, so we had PAR sensors going across the US, and you could see the PAR sensor dip.
wow,
So that was kind of cool. So stuff like that, just to engage.
That's so cool. Colin and I talk about this occasionally, where it's like, where do you put your resources? Do you put it in public engagement? Do you put it in your marketing? Do you put it in technical development? Like where do we need the most help in order to get the most funding or the most devices in the sea? And it's really a great question.
Yeah.
And storytelling always comes back, and I'm always like, oh, if only, right? So we've got time for probably two more questions. I think the blue cube is floating around there somewhere. Ooh, blue cube's over there.
So as an acoustician, when I think of scaling, I think of putting out 6 sensors. And so I love the way you guys hear it. So far, I've used the word scaling. And so if we think about a huge ocean with tons of data, what's your vision for who would put out the sensors and who would use them? Or would it be like, I'm guessing your answer could be everybody and everybody, but national institutes, weather, NOAA, the Navy, where do you think that's going?
This is an awesome question. So the first one is like, just to clarify, who's putting all these out there? Sofar has a really fun answer for that, and I want Dan to weigh in. And the other one was like, okay, well, who cares, right? Like, who's using that? And I think for each of our panelists, we might actually have a really interesting and different answer for each of those things, or maybe they're all the same. That could be interesting too. But Dan, if you wouldn't mind addressing who puts all those sensors out there, and then we could pass it down the line. Who cares about the data that you're collecting?
Who puts the sensors out there? Right now, we do. We knew that we wanted data, so we we're able to find ways to be able to use ships of opportunity and get the data in the places we want. But again, that may not be the most scalable motion to get, all the data that we need. And so, yeah, I think it's going to take a bunch of different tactics, different government agencies, different commercial groups to find ways, and having that data be unified is going to be core for everyone to be able to use it. Because at the end of the day, when we start talking about stuff at scale, no one wants the hardware, right? I know we all love the hardware, it's great, but it's the data that is what matters to most people.
Yeah, and so just to restate the question, so like, who cares about the data? I think Caesar, you're up.
Yeah. So what we did with our over 160 smart mooring buoys that we donated worldwide was that basically we gathered applications from people around the globe that want to use this data, that would benefit from it. They might do research projects or monitoring projects. And we got people like John reaching out to us, asking for a buoy. So we distributed these buoys to people that actually needs the data, that will take care of the buoy because they see something valuable in the data they're receiving in return. So what we do is basically we tell our users like, hey, you need to check on the buoy now. And they happily do it because they really want the data. So it's really being used by people who really needs it. And then they can share the data so everybody, so it spreads even more.
Yeah, I'm going to actually put an underline under that. So 160 buoys, and you personally, Aqualink, did not install a single one of those, right? Those are all volunteer installed?
Yes.
Yeah. And then Dan, I mean, didn't we trick some of our customers into installing them for us? So that's kind of fun, right? If your customers are global shipping companies and they really want a part of the ocean instrumented, it doesn't take a lot of work to say, hey, would you throw these overboard on your way? And so if you look at the big map, all the little yellow dots that are out there, that wasn't me, right? That wasn't us in our little 18-foot fishing boat here. And so I think, what we're hearing is that at scale, some of this might change, but to get to this scale, hundreds of sensors past the sixes, the dozens, it takes kind of a different approach. And I don't know if that's going to work for every situation or every piece of hardware, but we've built our hardware so that it would be able to be used like that. And we put that in, we baked that into the design, which is, I think, maybe a kind of a novel approach there. And then Caesar, you may have touched on this a little bit, but just briefly, who's consuming your data? What are your users mostly interested?
Well, who is using it? That would be like, we have state agencies, NGOs, local communities, universities, and everything there in between. And they also share data with each others. So one might have a buoy, but someone else is using their data. So it spreads kind of rapidly. And what was the second part?
So essentially is who's consuming the data, who's like really checking their website every day, hitting refresh, like what are your power users like? Just describe them to me.
Yeah, so Aqualink is like two sections, right? We both have our interactive platform where you can check the data, you can use the data for your own purposes. But it's also the other section where we have that fleet of data. So especially those people who take care of their own buoys, they have deployed their buoys in a specific location where they really care about the data. So they obviously on Aqualink a lot, checking their own data. But it's also the other section, the global section, where people really come, and you might want to look at your own local reefs, or you want to look at like globally what's happening. For example, we have a water quality group in Maui that are monitoring 50 sites in Maui for water quality. And what they did is they used Aqualink to visualize the data and bring it out to the public. So now the public, before they go to the beach, they can use Aqualink to both see the temperature, wind and wave data and the water quality measurements at their local beaches. So it's a bunch of different applications in a different part of the world.
And I've lost track of time a little bit. This got super interesting. So, but I'm still hoping to get to you two. Who's using the data? Who's looking at? Is it just you and the prof, or you guys
No, we got everyone looking at it.
Everyone, yeah.
It's mostly, I mean, it's word through the grapevine. So if something cool happens, we'll tell the class, or I'll just be discussing with other graduate students, and then it kind of flows from there. Where it's, if something cool happens, like, hey, check out this spike, the oxygen went down. And then someone else is like, oh, it could be this. And then they're like, oh, let's check other data. Let's check climate data. Let's check the GLODAP data. And then it turns into this huge cascade of things. So I think, yeah, it's mostly, I would say students and profs, at least from my perspective. Don't count us out. We're always looking at it. We're just refreshing the page whenever we get a question.
Right. Awesome. And then you touched on this a bit with Elkhorn. You guys have kind of both a scientific and outreach component. Would paint a picture of who's really interested in the data you're creating there.
Yeah, I think it's a mix, there's a lot of it's the managers, so we send a lot of our data to the regional board when they're doing a TMDL, a total mass daily load. They're looking at our data because we have this massive historical data set.
Yeah.
But then the OOS community, the IOOS or Senkus, the Central Coast, they use a lot of our data, and that's the OOS is all over the US because the NERS are national. And then for taking off that hat and putting on the OPOR hat, it's mainly the community that's using the data.
So these are people like, I'm going to check the conditions for I go take a dive school out there, or if I go fishing.
It's for how they're managing their fishing.
Yeah.
So they're making decisions on how should we avoid maybe fishing in this area because it's getting some heat stress. And then the historical data that we generate, they can learn about the different areas of the reefs.
I could really do this all day. I really
Yeah.
could, but we've got a bunch of folks lined up to continue. Could everyone join me in welcoming and thanking our panel? Thank you guys. Thank you. Thank you for being so generous with your time. Dan, do the questions okay? Great. All right. So we're moving into the